All right, so welcome to today's session. We're going to continue from where we started last week, and we're going to start talking about system views. Before we talk about system views, I'd just like to do a quick recap of the system databases which we mentioned last week. You see, when you talk about system views, all the metadata about your instance is stored inside the system databases. Most of it is in the master database. And I remember last time we talked about the fact that the master is the guy who has all the information about all the other databases, about how the system is configured, about where configuration files are located, and so on and so forth. The model system database is like a template. Every time you do create database, the database engine will take a snapshot, or we will copy the configuration of your model database, and that is what it will use to create that database. We can experiment that right now. Now let's assume I go to my model database and I make a change that that depicts how I always want my databases to look like. For example, let's assume I want my databases to be called, how do I put to start with an initial size of, let's say, 10 instead of the default 8 MB. Okay. So I just change it to 10 MB for that, just as a test. When I do that, whenever I say create database test DB, I don't have to do any other thing. I don't have to supply any other parameters. Once I do this, it will use all the configurations of the model database and it will create the test database. I don't have to, but typically, if you wanted to create a live database, you have to provide the details in order for you to be very explicit about what you want that database to look like. So let's see what has been created here. So when I go to the properties of this database, I expect that it has picked up the exact settings I have done for this database, for the model database, 10 GB log file, and so on and so forth. Now it picked this path somewhere else. Where did it pick this path from? When you go to the settings of the instance, you'll find out that there is a setting for you to determine where your databases will be written to. That's where it picked that path of C and E. Otherwise, it would have picked the same thing as the model database. Now, let's do another experiment. Assuming I change this, I come and say, okay, I no longer want my initial size to be 10. I want my initial size of files to be 12. This is D12, and then 12. And I change that for the model database. Every time I create a new database on the instance, to pick up that exact same configuration. Let's just check that. Let's check that. Refresh this. We see test DB1 properties, and that the file is 12, right? And that can happen for many other settings that are available for databases. In effect, model is like the template which SQL Server uses to create your databases. Every configuration item which you don't explicitly specify when you issue the create database command, it will pick it up from the model database. All right. So the MSDB stores everything that has to do with jobs, what you call operators, what you call even everything that has to do with automation. Everything that has, even your maintenance plans, everything is stored here. Everything that is worked on by the SQL agent is also stored in MSDB. So if you want to find even things about like database mail, everything automation is stored here. And then the temp DB is basically like a scratch pad. Everything, for example, when you want to do sorting, typically when you're sorting, we call it when it spills over, when it goes beyond the memory capacity that you have, it's likely that it will start using the space in tempdb to do temporary sorting. You know, when you're doing large queries that require a little bit of sorting, order by or group by, part of that sorting can be done in the tempdb. If you will be done in the temp db. Other things happen there. For example, if you're doing things like index rebuild, you can specify that the index rebuild session should use tempdb to do sort operations, and so on and so forth. So these, most of the system views that we were going to be dealing with are actually stored either in master or in the MSDB, as you will see eventually. So let's proceed. There are 4 different kinds that are defined within SQL. We'll just talk about the first 2 really, but there are 4 different kinds: the catalog views, the dynamic management objects. The dynamic management objects are split into dynamic management functions and dynamic management views. And then you have the compatibility views and then data tier application views. These are examples of the catalog views. They are basically metadata. They explore the structures, things like sys.databases, sys.tables, sys.indexes. So if I come back to my instance here, I can I go into the 1 minute please. I go into the sys.databases catalog view. I can see all the databases in my instance. So let's start from sys.databases, right? Okay. So where am I? I am in the default instance. So when I query it, it will give me a list of all the databases that are in my instance, as well as their properties. Now you see that you have a lot of columns here in this catalog view, a lot of columns, which is important for you to understand what it is all about. Create date, when the database was created, compatibility level, and this has to do with, is this database compatible with SQL 2019, 2016, 2017, and you also see that most of them are 150, that is 2017 actually. When you go to properties of the database, you will see the options and you see the compatibility level. You should see here. For some reason this is not showing up. Let me check the new one we just created. Okay, that database was created from the previous version. Options. I will need to check this data. Typically you will be able to set the compatibility level here. So 150 is 2017. All right. So if you want to know everything about what this catalog view shows us, you can just select the catalog view name, and this happens for any function, any catalog view, any most tools that you're using inside SQL Server. If you do function F1, it will take you straight to the record of this catalog view on docs.microsoft.com, and it will tell you about the catalog view itself. Contains 1 row per database of instance. You can read about this. You can know what all the columns mean. Integer, this is compatibility level, which we are looking at. It tells you the data type of that column and tells you what it's all about. Integer corresponding to the version of SQL Server for which the behavior is compatible. And then it gives you a record. 150 is SQL Server 2019. My apologies. 150 is SQL Server 2019, and so on and so forth. It tells you, okay, is read only, tells you whether it's read only and the possible values, and so on. So a lot of detail is available on books online for all the catalog views, all the dynamic management views, and all that. So now the same thing with sys.indexes and so on and so forth. It gives you all the indexes on the environment. Now you see, we flat out like this with these catalog views looking like this. Typically you may not see their use if you do not develop or acquire. So it's either you develop it yourself or acquire queries that take advantage of these catalog views to give you a description of your environment. Let me see whether I can find an example. Let's see, scripts. This is DBA01 scripts, DBA02 scripts, move databases. Let's see. Okay. Okay. I'll just get a flat example. I may not get an example that is using that exact one. Oh, sorry, that we already used that. Okay. Okay, let's see this. All right, so this is a query that uses sys.master files, and I basically would incorporate it and determine which columns I want, the aliases and all that. And let's see, TSQL, provide the database name there, v4. All right, so I can decide to combine different catalog views. Let me try to do that. New query. From sys.master files. This.databases. Let's see. Typically, these guys will have something in common, maybe a database ID. So let's just check. So they have a database ID in common. So I can combine these two queries with a join. Let me see. With a join to be able to get something informative. Current location online. I'll just give an example that may not be so useful, but
okay,
just to give us the idea. Now you can see that in the case of sys.databases, I don't really have a column that tells me where its files are located. But in the case of sys.masterfiles, I do have that. So in order to get a more complete picture of the database, I can combine these two queries. I can say select name, select let's see, from sys.databases as D, join.
in your query, what are you selecting? There's nothing there.
Join sys.master files as what? M on D dot database ID equals to M dot database ID. So this is the join query where D dot name equals to what? TSQL v4. So what do I want? I want D dot name as database name.
Okay.
I want what do I want? Physical file name, M dot physical name. I want D dot status, state rather, or state description. Maybe I want what else? Do I want? M dot name. This is M dot name as file name. Okay. Let's put that in correct because it's a system. It's a system name. All right, D dot name. Right. Okay. So I've just created a small query that will combine two catalog views to give me a lot of information about my databases. So I have two rows. I have a database name, the name field coming from my sys.databases table. I have the physical path names of each of the files coming from my master files catalog view. I have the state of the database coming from
Okay.
my databases catalog view, as well as the file names. Notice that you have of course, this is from joins. You have a name field from the master files catalog view. You also have another names field from the databases catalog view, but these are referring to different things. This is the name of the database. This is the name of the file in this case, if you can see clearly. So what the point is that you can given alone, these catalog views provide so much information that it may not be useful to just query them like that always. You have to develop queries or acquire queries that have been, developed to utilize these catalog views in order to examine your environment. And you see that there are a lot of them. If you go to GitHub, you find a lot of already made queries. People like Brent Oza and Itzik Bengan and so many people, Paul Randall, they have free scripts out there that take advantage of these tables. Sometimes you may have to develop yours. This is another interesting one which utilizes a whole lot of stuff, or dynamic manager functions, catalog views, and so on to get information about allocation, what you call allocation units. This is a whole new topic. So the point is, these catalog views, they are simplistic, they look simple, but you can use them to examine your environment in detail. So that's what catalog views are.
Okay.
All right, so these are examples of catalog views which we have in SQL Server. Then you have what you call dynamic management views. The key word here is dynamic management views, and you also have functions. One of the key word is dynamic. The basic difference between a catalog view and a dynamic management views is that a catalog views contain static data, which means most of the time, except I have introduced a new database, except I've introduced a new database, every time you query sys.database, you should get the existing list of databases, right? But there are other
Yeah.
kinds of views called, let's say, sys select from sys.dm exec. Let's do connections. This is not a busy environment, so let's do connections. Now, sys.dm exec connections, there are key things about the naming of dynamic management views. You have sys.dm standing for dynamic management. Then exec. Every time you see exec in the name of a dynamic management view, you are talking about a dynamic management view that has something to do with ongoing execution of sessions, transactions, queries, and all that. That's what it basically has. So, and then it gives you a descriptive name, connections. So this guy gives you a row for each connection that is upon in this database. Now let's employ our function F1 to again see the details of this dynamic management view. Sysdm exec connections applies to so and so on, returns information about the connections established to this instance of SQL Server and the details of each connection. Then it will give you all the meanings of all the columns involved. So you see here, I told about the net transport. I didn't mention it as net transport, but I told you that when I'm connected to an instance on my own computer, I'm not likely to be using TCP. I'm likely to be using shared memory. And when that happens, you can see this is my connection. Okay. Now you cannot see my username here. I have to combine it with another catalog view for you to see my username, but you can see that I am on my local machine making this connection. I'll show you another script that combines 3 dynamic management views to give you information about who is connected from where and why, those details. But all my connection detail, all my sessions are not using TCP. They are actually using what they call shared memory in SQL Server. And I cannot see any port number because I'm not using PCB, obviously. But I can see who that I am the one logged in the local machine. Now, typically, if you're in a production environment, you will see all the sessions that are logged in, whether they are using TCP or not, what their names are, and so on and so forth. And if you combine this with what do you call it? Inner join sys.dm exec sessions, sessions, you'll be able to see using the session ID. Okay, so let's put the aliases. Exam connections, connection C, sessions S, sys.dm exec. Sessions on S on C dot session ID equals to S dot session ID. You'll be able to tell who it is that is logged in. There's a login name, host name. I think there's a login name column on sys.dm underscore exec underscore sessions, and tells you the name of the person who is logged in, his domain, and of course the connections will tell you the client address, where he's logged in from, and so on. And like I said, these are dynamic management views, so they are transient. You would agree with me that in a production environment, every time you query this, you will get a different data set, because at every point in time, somebody else is logging in, somebody is logging out, a session is being created, a session is being terminated, it's being closed, and so on and so forth. So that is
jobs are running.
basic difference between the catalog views and the dynamic management views. These are essentially looking at things that are transient in nature. There are 4 types defined. There are 4 groups of dynamic management views. The DMOS exec views, they contain low-level information such as memory, locking, scheduling, etc. The tran views, details about current transactions. The IO views, details about IO and network and disk. The DB views, details about databases, objects. There are actually 5. So the 5th one is the exec views. I actually skipped it. The exec views contain information about execution of user code. So there are 5 DMV groups which you essentially would be playing with inside SQL Server. All right. So let's go back here. Let me dig up one of the scripts that is already made and give a few examples. This is an interesting script that combines sys.dm exec sessions, sys.dm exec requests, and sys.dm exec SQL text. Once you run it, and sorry about that. Okay, let's go to. I'm going to 1 minute. 1 minute.
Okay.
What do you want? What? Okay. All right, so this is an extensive, what do you call it? An interesting script which combines three different dynamic management views to give you a view of what is happening with SQL Server currently, and it's very good for troubleshooting, right? So if I run this, you can give me who is logged on now, what is he querying. So what I'm going to do, I'm going to start a query in another session, and for me to make it static, I can just do this. Select star. Let's use till, then let's just say create table. Tab 1 id int. Okay, so let's do that. Then I just open the transaction and do that. Now I go here. Into tab 1. All right, so once I query, I can, because I did a wait for 10 seconds, I can tell where's my query is. So it tells me basically who is logged on, how long he's been waiting, what the exact query he's running at that time, and so on and so forth. So this entire query gives me all that detail. I have combined it with you have arrived at it by combining different dynamic management views. So let's just roll back this.
Okay. Can I quickly ask a question? Is that the script that normally you run? I mean, that is the DB team.
So as long as the session is not active currently, I won't be able to see anything in this view, DM exec requests. And once again, you can always check with function F1 what the view actually contains, and that will help you even if you're getting the script from somewhere else. The details of what that script does, you can always get it from Microsoft documentation. So system exec requests returns information about each request that is executed in SQL Server. So what is the difference between a session and a request? Is a session can be idle or not. When a session is active, it is executing a request. You can think about it that way. When a session is active, a session is the client and the server have negotiated and established a relationship, and then when the client begins to give the server a job to do, it's active, and in SQL Server we call it a request. In some other database platforms like Oracle, you have everything is inside $v session or $gv session, and you have a column that differentiates whether the session is active or inactive. But in this case, active sessions show up in DM exec request. All right, so let's go back to our slides and see what we have in store for us there. Okay, so the next step is for each one to install his version of SQL and try out some of these things. These are the minimum requirements. But you see, almost every computer in the world has exceeded these minimum requirements. But one thing you need to pay attention to is .NET framework. Make sure you have the current version and the current version compatible with your version of SQL Server. That's the only thing that may give an issue. But for most server environments, you have the current version. Okay, if you are doing this installation in a production environment, it is recommended that each component. Remember, we talked about components of SQL, whether it is the database engine or SQL Server agent and so on and so forth. Each component should have its own service account. That is a security measure you are taking. And then you typically would partition that the hard drives with 1 MB initial offset. This has been the default setting since 2008, so it's actually dated. And then you use 64K allocation unit size. These two recommendations about the hard disk, there's a long discussion on it on the SQL Server documentation and many forums around how to configure your storage properly for databases, for SQL Server particularly.
Yeah.
And typically when you're doing the formatting, the allocation unit size you should use is 64K. You have to prepare separate drives for data and log files. A lot of contention is around this as well, especially these days when many people are using storage array network SAN, where in that case some of these things are already taken care of by the storage layer, and you just go ahead and do your installation. So some of them are dated, but it's good knowledge to have. Particularly someone like Brentuza, I had an interaction with him on it via chat, and he tried to prove very clearly that separating data and log files doesn't really matter anymore in this day and age. All right. So these are some of the activities you want to do after doing your installation. Confirm the service account has the correct operating system permissions. Assign log pages in memory. There is another video I have where I try to demonstrate the fact that SQL Server can consume the entire memory on your server if you do not cap the allocation to SQL Server. When you do cap the allocation to SQL Server, it is important that you assign a privilege called log pages memory to the service account that is running SQL Server. This is also detailed in that video. And there's another limit which you configure, maximum degree of parallelism. There's a small script you use to check the desired or the appropriate maxed up level. And then you do other activities like creating maintenance jobs. All these are different, can be covered as different lectures in themselves. And then disk pre-allocation. Disk pre-allocation simply means for each database you want to create, decide on how large it is likely to get and already allocate that size to it, rather than creating a database and then it has to keep growing and growing and growing. We made an allusion to this when we created this database. Now, typically, if I wanted to create a database, I would not just say, where was that script? I would not just say create database. I would actually determine, let's assume we're doing it graphically, new database. I've actually determined the initial size and I say, okay, let me do some capacity planning. I know my database is going to be 100 MB eventually, so I just give it 100 MB from the start. That way, SQL Server doesn't have to waste energy, so to speak, waste energy kind of like allocating the storage, because when there's a lot of auto growth happening, your database tends to be fragmented and it impacts performance. You have to do some maintenance tasks to recover. So it's better to give a good initial size and to give a good auto growth. In production, my auto growth settings won't be this. My auto growth settings will typically be 1 gig or 500 MB depending, so that there's minimal fragmentation on my database. So that's about pre-allocation. Determine how much your database is going to grow from the beginning and give that database that amount of space, so you can try to avoid growth entirely. That's the whole point. All right. So that's for that. So there's something called unattended installation. Hello, Eben.
Come again.
Any questions so far?
No, please.
Right?
Yeah.
Okay. unattended installation implies that I can have a script that I'll tell all the details that I want to provide for me to do an installation. And SQL Server, the SQL Server documentation actually gives details on how to use this unattended installation commands. I have a sample script which I've used. If you want it, you can put a comment in the video, give me, and then maybe privately I can send you a copy of it. All right. So there are other aspects of this study. Starting SQL Server options. You can either use command line, net start SQL Server. So we'll just demonstrate that quickly in this session. So I still have my session here. So I can just do net stop MS SQL Server. Sorry. And then I confirm, stopping, and it stops the agent as well. And then I can decide I want to start it again. So this is the command line version of what we did. Okay. And I then also have to start the agent later. All right, so I can also do this for the named instance. It typically looks something like this. So basically what it is instead of saying MS SQL Server, you say MS SQL, the dollar sign, and then the name of the instance. This is the case for named instances, right? Okay, there are other ways to start SQL Server. Another way is to navigate straight to the installation directly of SQL and then call the SQL Server binary itself, provide some parameters, and then you will be able to start it. And remember the last time we actually talked about where our SQL Server binaries are located. We saw that in the startup parameters that it is actually here. So I can take this, it's in the bin directory of this. So if I go back to my command line interface, and go to bin, if I type, what do you call it again, there by find string SQL. Okay, so I have SQL SVR some SQL Server exec here. I can decide to start by saying SQL Server, then I'll put parameters I want. Sometimes you want to start in single user mode. There's a command for that. Sometimes you want to start with minimal configuration. Maybe you cannot find your temp DB. You start with a -F, and so on and so forth. So any questions, you do well to post in the comments, and if I have the answer, I'll give you. And then you can take advantage of these links. This partition alignment link talks about what I mentioned earlier about how you configure your disk environment for SQL. The Microsoft recommendations is also documented here. Maximum capacity specifications is documented here. And of course, new features in the recent versions at the time the slides were prepared also documented. Then earlier in the last video I had made reference to SQL Server builds, the blogspot.com. So thank you for your time. If you want to participate in certain activities which some of the people who went through this class participated in, you can install a default instance of SQL. It can be a new version 2019. Install a named instance with Slipstream, applying Service Pack 4, and then install another instance and just practice those activities. These are key activities for a DBA. All right, and then you can also go ahead and configure and limit the memory of the instances to 70% of the memory on your machine. I mentioned that I had a video on this already in another video about how to do that configuration. You can consult that, and then configure different port numbers. So those activities will help you embed, so to speak, the lessons in this lecture. All right, thank you for your attention. Much appreciated.